All right, hey everybody. Here is a video key for problem set 3.8b. This is going to be very similar to our previous problem set 3.8a, except now we're going to talk about perpendicular lines. So let's look at A right here. What do you notice about the appearance of segments A, B, and CD on the graph on the left? So they certainly appear to be perpendicular. They appear to be perpendicular. And then we're going to figure out, well, what does it mean for lines to be perpendicular? Remember, that's when they form a right angle. But then what has to be true about the lines to show that they actually are perpendicular? So let's find the slope of each segment, A, B, and CD. We can just count here. So from A, I go up 1, 2, 3, 4, 5, over 1, 2, 3, 4. So that slope is 5, up 5 over 4. And for line CD, so that was the slope of this one. For line CD, again, we can just count, and we can go down 1, 2, 3, 4, 1, 2, 3, 4, 5. So it was down 4. Down 4 over 5. But notice how the green line is going downhill. So remember, that's a negative slope. So our slope of this one is negative 4/5. Now, what do we notice about these slopes for part C? Well, notice how this is 5/4, this is 4/5, so they're flipped, which is called reciprocal. And one of them is positive, one of them is negative, which are called opposites. So they are opposite reciprocals. Again, opposite means one's positive, one's negative. Reciprocals just means it's like a fraction flipped. So they are opposite reciprocals. All right. So let's come up with the slope of perpendicular lines postulate. It says in a coordinate plane, two non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. So remember, if and only if, that means we could read it this way and say, if two lines' slopes are opposite reciprocals, then they are perpendicular. So remember those if and only if statements, biconditional. All right, so number one down here, let's do some problems. Are the following pairs of lines perpendicular? Well, let's find the slope. This slope is negative 1/2. The other line's slope is negative 2. So even though they are reciprocals of each other, because negative 2 is really negative 2 over 1, so this fraction flipped is equal to that fraction, but they're not opposites. They both are negative. So if both slopes are negative, they're automatically not perpendicular. They have to be opposite, one positive, one negative. So no, even though they are reciprocals, they are not opposites. Okay, let's come over to B. Let's find the slope of each of these lines. So the top line, we got to subtract 2x. So I'm going to write the x first, so you can do it like that. And then divide everything by 3, leaving us with negative 2/3 x plus 5. And then the line for B, or for the second line, I mean, just divide everything by 4, and you get 6/4 x minus 18/4. Let's reduce those, and you get 3/2 x minus 9/2. So the slope of our green line is 3/2. The slope of our blue line is negative 2/3. So if you notice, this fraction is the flipped version of that one, or the reciprocal, and one is negative, one is positive. So therefore, we can conclude, yes, that they are perpendicular. Okay? Number two, let's take a look at just looking at some points. Is the line passing through these 2 points perpendicular to the line passing through these 2 points? So again, we're just going to analyze the slope. So let's call this x1, y1, x2, y2, and do y2 minus y1 over x2 minus x1, leaving us with 2 over negative 5, or negative 2/5 is the same thing. So if one of the numbers is negative, then the whole fraction is negative. Remember, for slope, we're using this formula, m equals y2 minus y1 over x2 minus x1. Okay, and then let's try the slope between these 2 points, x1, y1, x2, y2. So y2 minus y1 over x2 minus x1, which is negative, so it becomes positive. So you get negative 5 over 2, which is the same as negative 5/2. Okay, so we have a slope of negative 2/5 and a slope of negative 5/2. Since they're both negative, they can't possibly be perpendicular. They have to be opposites, one positive, one negative. Notice, however, that they are reciprocals. They are flipped, but that doesn't actually mean anything. So no, the slopes are not opposites. And then I'll say, even though they are, reciprocals, but just them being reciprocals is not enough. Okay. Number 3, I kind of like this problem here. It says, given the graphs below, let's create a line perpendicular to segment RS through this point. So we're gonna create a line somewhere in this direction that is perpendicular. But remember, perpendicular lines have opposite reciprocal slopes. So let's find the slope of this line. So the slope of the green line, and again, we can just count. We go up 1, 2, 3, 4, 5, 6, 7, 8, 9, over 1, 2, 3, 4, 5, 6. So our slope is up 9 over 6, which is 9/6, or reduced is 3/2. So the slope of the line we want to draw, which we'll make blue, we need a slope. We need m to be equal to the opposite reciprocal. So reciprocal is 2/3, opposite makes it negative. So start at point A and just use the slope of negative 2/3. So we're going to go down 2 over 3, 1, 2, 3, down 2, 1, 2, over 3, 1, 2, 3. And if we draw a line connecting those points, then the line we just drew is in fact perpendicular to the line highlighted in green, because they have opposite reciprocal slopes. Okay, remember, pause the video and try problems, and then come back and watch the video if you haven't tried the problems already. So now would be a good time to pause the video and try this problem. All right, so let's find the slope of RS. So we're going to go down 1, 2, 3, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 3, over 9, and that's a negative sloping line. It's going downhill, so it's negative. So it's negative 1/3 when you reduce it, which means the slope we want down here, we want this slope to be positive 3 over 1, or just positive 3. So you go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. And I'm just going until I actually cross through the line, the other given line. And then we draw that, and there you go. That line is perpendicular to the given line. All right. Now we're going to write the equation of a perpendicular line. So if a line is going to be perpendicular to this line, then they have to have opposite reciprocal slopes. So our new slope, since the given slope is negative 3, we got to flip that, which is negative 1/3, and do opposite. So it's going to be positive 1/3. So that's our slope, and here's a point. Once we have a slope and a point, we can just use point slope. Remember, y minus y1 equals m times x minus x1. Here's my x1, here's my y1. So let's do that. And you get y minus 12 equals our slope, which is 1/3, times x minus 6. And I do want to solve these for y again, now that we're used to using this. hopefully, we can distribute the 1/3. So I'm going to do this times both of these, right? So we get y minus 12 equals 1/3 x, and then 1/3 of 6 is 2. And then just add 12 to both sides, and you get y equals 1/3 x plus 10. Okay? And we have another one here. Same thing, really. So go ahead and try it if you haven't tried these already. But the slope of the given line is 1/2. We're trying to write an equation of a line perpendicular to that. So our new slope is the reciprocal of 1/2, which is 2, and then make it opposite, so it's -2. So now we have a slope of -2, and here's our point, x1, y1. Using point slope from above. You know what? I'm going to use y equals mx plus b here, just so you guys can remember how to do that. So y equals mx plus b. So I'm going to plug in y, which is 5, m is -2, and x is -8, and then plus b. Okay, now find b, and you get 5 equals 16 plus b. Subtract 16, and you get b equals -11. Now we know m is -2. Right, this is m, and then, sorry, this is m, and then this is b. So we just plug those numbers in for m and b right here. And we end up with y equals -2x minus, oops, I wrote m. -2x minus 11. Okay, so that's the other way to do it. So I've shown you both now, either using point slope, which is this, because it uses a point and a slope, or slope-intercept, because you have a slope and the y-intercept. Okay, number 6. So, given the following points, is angle BAC a right angle? So, let's figure out if this is a right angle or not. So B is up at 22, -5. Or it's over at 22, -5, sorry. But basically what our picture kind of looks like this. We have BAC. You know, I'm going to put this on a coordinate grid, I think. So what it would look like is something like this. So A is at 210. So I'm just going to estimate 2 to the right, up 10. So point A is right there. Point B is at 22, -5. So 22, -5 would be like somewhere around here. Okay, I don't need it to be exact. And then point C is at -1, 6, which would be somewhere around here. Okay, and we want to know if BAC, so this angle right here, is that a right angle? And so what we need to do is show the slope of this, and then show the slope of this, and if they're opposite reciprocals, then we know that they form a right angle right there. So let's find our slopes. So if the slope of the blue line is going to be -5 minus 10 over 22 minus 2, which is -15 over 20, which is -3/4 when you reduce it. And now the green one is, so the slope of the green line, sorry, let me label this. This is the slope of AB. So now the slope of BC is 6, sorry, AC, finding the slope of this line, AC, 6 minus 10 over -1 minus 2, using these points right here. Okay, and that is going to give us -4 over -3, which is 4/3. And this is the slope of AC. Since these two, look at those, they're reciprocals and they're opposites. So since the slopes, so angle BAC is a right angle, because these two lines are perpendicular. So angle BAC is a right angle because the slopes of AB and AC are opposite reciprocals. Yay. All right. Now let's do part B. I got to shrink all this down so I have some space. Uh-oh, I missed something. Oh no, what did it do? All right, there we go. Okay, so now is AD parallel to BC? So let's put point D on here. So D is 25, -1. So 25, -1 would be way out past point B, and then, hold on, sorry, gotta move this. So 25, -1 would be somewhere like right here or so. And it wants to know, is AD parallel to BC? So now we have kind of some new points here. So AD is this one. Is that parallel to BC? So don't judge it by the picture, because the picture is certainly not drawn to scale. I just kind of put points roughly where they would be. So let's find the slope of AD. Okay, which is going to be -1 minus 10, just using the 2 points here, over 25 minus 2, which is -11 over 23. So remember, if these two lines are parallel, then they'll have the same slope. So let's see if they do. And let's go with gray, why not? And then we have the slope of BC is 6 minus -5, so 6 plus 5, over -1 minus 22, which gives me 11 over -23. And so remember, if any part of your fraction is negative, if there's a negative on top or bottom, the whole thing is negative. So these are, in fact, the same slope. So now we can say, yes, AD is parallel to BC because they have the same slope. Sweet. All right, number 7. Let's write an equation of a line that is perpendicular to the line y equals -4. So remember, y equals -4 is a horizontal line. So a line perpendicular to a horizontal would have to be a vertical line. A vertical line is always just x equals. So we're going to have x equals, and looking at our point, which one's x? -7. So x equals -7 is the equation of that line. And finally, number 8, very similar to what we did on the last problem set, we're going to find this missing number. So we're going to find n so that the line that passes through these 2 points is perpendicular to this line. So if it's perpendicular to this line, then the slope we want is opposite, so positive, and then reciprocal 1/3. Okay, so let's set up a formula for slope. x1, y1, x2, y2. So 7 minus n over, that 7 looks horrible. 7 minus n over 8 minus 2. And we want that to equal 1/3. So let's simplify this. You get 7 minus n over 6 equals 1/3. Multiply both sides by 6 to give you 7 minus n equals 2. And then subtract 7, and you get -n equals -5, which means n equals 5. So when n equals 5, and that's the y value of this point, that will be the line passing through those 2 points is perpendicular to that line right there. I hope you enjoyed it.